Hey everyone, welcome. Azure Cosmos DB Live TV, episode 34. And I've got with me a couple of guests, some friends of ours from Striim. How are you guys? Edward, Jordan, good to see you.
Great to see you. Thanks for having us.
Yeah. Edward, do you want to start off and just introduce yourself?
Yeah, sure thing. So, hi everyone. I'm Edward, and I'm a solutions architect on the partner team here at Striim.
Yeah, and Jordan?
Hey everyone, I'm Jordan, also a solution architect here with Striim on the partner team.
Great. Well, welcome to the show. This is going to be a pretty cool episode. You guys make, I guess you could call, is it like ETL or data migration, or how do you just tell me about Striim and the service you guys create?
Exactly, yeah. So typically we call it streaming ETL, where you can continuously ingest from any data service, typically a transactional database, or today we'll be focusing on Mongo, and then write out to any number of Azure data services. Today we'll focus on Cosmos DB, but you can also write out to transactional databases, Synapse, and other services as well.
So how many databases do you guys have? I know, do you call them connectors or adapters, or what are those things? How many databases are we talking about?
Exactly, yeah. So we call them adapters or connectors, pretty much whatever you'd like to call them, but there are over 100 out-of-the-box connectors that you can just drag and drop.
Wow, that's pretty cool. That's a lot of different databases. Wow, okay. And this is all within Azure, your service. Do you run in other clouds as well?
Yes, we do. So ultimately, Striim runs in a VM in your environment. That could be on premises, it could be through Azure or any other of the public clouds.
Okay, so explain that provisioning model, because different ISVs have different models where you're either like what you guys do, you're injecting inside a VM inside a user subscription, or in some cases they're pure SaaS and they integrate over the wire, or in some ways, or in just different ways. So yeah, explain that to me. So if I go and I provision, go in the marketplace and I say, give me a new Striim account, walk me through what kind of happens next.
Exactly, yeah. So you can deploy Striim directly through the Azure Marketplace. There are a whole host of solutions there for specific targets. And there's also pay-as-you-go models as well. So you don't have to sign up for an annual subscription. You can just go online and use Striim for a minute, a few hours, and migrate your data. Underneath the covers, what that will do is it will deploy a Linux VM, install Java on it, and then install Striim. So this is all in your end environment. We don't touch the data at all, which helps get around many of enterprises' security concerns.
Got it. So I'd also, I guess, if I have my data hidden into like a subnet or something, I'd have to configure the VNets as well, I guess, to be able to add that, right? So do I have the option to deploy the VNet or the VM into a particular VNet or subnet, or do I just configure that? Okay, makes sense. So that's good. So you make it easy for folks to be able to integrate Striim into their existing deployments, and then connect up their databases in there. And I like your model. Like, some customers may just want to do a one-time migration. Some customers need this stuff live forever, right? They're building systems and maybe doing modernizing. I'm guessing you're probably used in a fair amount of those types of scenarios where they may have legacy databases and they want to modernize these things for the cloud. Is that kind of a common scenario for you guys?
Exactly, yeah. And even with the one-time migration scenario, we typically see customers keeping their source and targets in sync for a period of time, really to test that the application works on top of whatever new system that they're migrating to.
Makes sense. They want to double write the data basically, and then compare side by side, make sure things are cool, and then someday say a prayer and cut the cord.
Exactly.
Okay, cool. So today you're going to show how to do a Mongo migration. So this would be like a Mongo that's like sitting in a VM, but it could potentially sit anywhere, I guess. And then you're going to migrate that into a Cosmos account with our Mongo API. Is that the scenario we're going to do today?
Exactly. And
Okay.
Jordan will also share some of the cool processing that you can do in flight within Striim.
Got it. So I know you wanted to talk a little bit more about Striim overall. So yeah, you want to walk us through kind of what you wanted to show us, and then we can get to the cool parts that Jordan's got later, the demo.
Yeah, thanks, Mark. So I guess I'll go ahead and give a quick background about Striim. And then I also wanted to talk a little bit about this cool new program that we have in place. So recently released is this migration service for Azure databases. So kind of introducing dessert first here. So we have this program that can help subsidize the cost of Striim for one-time migrations to Azure. So we classify that for any use case of 12 months or less. And we kind of covered a few of the data services that Striim supports, and we'll cover more later. But specifically around this migration program, we support Mongo, Oracle, Postgres, MySQL, as well as MariaDB as a source. We'll be adding Cosmos DB CDC shortly as well. And then on the right-hand side, in terms of targets, can write out to Cosmos, which we'll be showing today, and then Azure DB for Postgres, or MariaDB, as well as SQL DB. So if you have a use case that you think would be a good fit for this program, please reach out to partners@striim.com. I would be happy to talk through the use case and explain more about this program.
Got it. And I'll put your email address up there and just leave that for folks.
Awesome. Yeah, thank you. So getting into what actually Striim does. So as we were talking about earlier, Striim is a streaming ETL platform that enables real-time data movement for analytics, operations, and streaming. So oftentimes we'll see that companies miss out on some of their most valuable data when they rely on batch technologies. So if these are really mission critical systems where you can't afford any downtime, Striim really liberates this data and allows companies to achieve digital transformation through these streaming data pipelines. So to give a little bit more context about the background of Striim, Striim was founded by the same founders as Golden Gate Software, or now Oracle Golden Gate, if you've heard of them. So Golden Gate really pioneered the use of log-based change data capture to turn any production database into a continuous streaming data source. And at Golden Gate, before selling to Oracle, they had a customer advisory board, which really allowed them to see into the future of what people were asking for their upcoming use cases. And there were two main themes that kept on coming out of this. The first was the ability to ingest from non-transactional sources and write to non-transactional targets. So we'll be showing that off today. And then the second ask was, or people were asking, hey, it's great that you're moving my data, but can you transform, enrich, or process it in flight?
Yeah. Makes sense. People want to, I mean, if you're putting it into a different database, it's probably not often you would want it exactly the same, right? So makes sense.
Exactly, yeah. So then the team came back together really to found Striim from the ground up with those two main ideas in play. So as you'll see in the demo, Striim runs in a VM in your subscription. There's a UI where you drag and drop these out of the box connectors that we've been talking about. And ultimately, since Striim is a platform, we typically see it enabling three different use cases. First is cloud adoption. So zero downtime database migrations from on-premises or other clouds to Azure. With that log-based CDC, you can keep the source and targets in sync. And it even supports bidirectional replication. So if you have a requirement to be able to fail back to the source database, you can always do that. Second use case, kind of an evolution from this one-time migration, is continuous data integration. So that's where you're not planning on shutting off the source, but rather continuously keep it in sync with today we'll show off Cosmos, but perhaps Synapse or other services as well. And then lastly, you have the ability to run SQL queries or even Java code on your data as it flows through the pipeline. So we've seen some customers move their streaming analytics to actually within the data pipelines themselves. Just quickly, you can see Striim is really industry agnostic. So since we focus on the data layer, you'll see a lot of different verticals, probably quite a few names that you know here. So really focusing on the enterprise space where there are high volumes and zero downtime is a requirement. We've already covered a little bit about this, but where you select these out-of-the-box adapters to create your data movement applications. In terms of all of the sources on the left-hand side of the page there, Striim supports log-based change data capture for, again, Oracle, SQL Server, MySQL, Postgres, HP Nonstop, Mongo, and others. There's also a component called an incremental batch reader, which allows you to read from databases or data warehouses on a polling basis. Also support SaaS applications like Salesforce as a source, Kafka and other messaging queues, log files, as well as IoT devices. Then on the right-hand side, on the more interesting part here, in terms of the Azure data services that Striim can write to, we support writing to Cosmos DB, either the SQL, Mongo, or Cassandra APIs. This is a cool example where we work directly with the Cosmos DB product team for a solution for the world's largest retailer, where they had a requirement to consume 1 million RUs on Cosmos DB Cassandra API. So we did a lot of performance testing directly with the Cosmos product team to build out a solution for them. Also support writing to Synapse for analytics, DB for either Postgres or MySQL, SQL DB MI, storage tier, HD Insight, as well as event hubs. So now probably getting into the more interesting piece here. Shortly, I'll go ahead and hand it off to Jordan, who will be showing a migration from an on-premises MongoDB to Cosmos DB. So with that, I'd like to hand it off to Jordan.
Yeah, cool. Just a question from one of our viewers. Do you have the option to migrate data from NoSQL Cosmos to Mongo? Actually, I think he kind of clarified NoSQL to NoSQL. So it looks like from your diagram, you can go any direction, basically, from any cloud. So it doesn't matter what your source and target is. You've got an adapter for it. You can go either way with that. Is that true?
Exactly. The one caveat that I would add is currently there is not a Cosmos DB CDC adapter, so you cannot use Cosmos DB as a source. But that's coming out very shortly.
Got it. Are you building that on top of our change feed? I'm guessing?
Exactly.
Yeah, makes sense. Yep. All right. All right, Jordan. Over to you. You're gonna kind of show us how we can build a migration to migrate Mongo and a VM into Cosmos.
Yeah, exactly. Thanks, Mark. Thanks, Edward. So yeah, the demo today, just really want to show you what your Striim applications could look like for an online migration from Mongo to Cosmos, Mongo API. Also, it's going to show some of our processing capabilities. So in this case, you'll see us actually embedding documents into existing documents on the Cosmos side, something that a few of our existing customers have requested. So what you're looking at here is the Striim web server UI. So Striim ships with this UI, and this is where you'll create and monitor your data pipeline applications. We're at the home page here. So on the left, we have dashboards. Here you can create drag and drop widgets populated with SQL queries to visualize your data or metadata in real time. And then what we call apps are all of your data pipelines or data flows from some source to a target. So this is where you spend most of your time in Striim. And then lastly, you have the option to preview any data files you have local to the Striim VM. So going into the applications page here, you can see I've organized some of my applications into different groups. So looking at this group here, I have 3 different Mongo applications. One being the Mongo to Cosmos Mongo initial load application. So this is what you would run first, moving any existing data you already have on your Mongo source. And then that followed up with the Mongo CDC application, which captures any of those live replication changes that you want to replicate to Cosmos. So any inserts, updates, and deletes, for example. So I'll jump into this application first, the CDC application, just to show you what a minimal configuration in Striim could look like. So I just dragged and dropped my MongoDB reader from the source, dragged and dropped my Mongo Cosmos DB writer from the target list, filled out their connection properties, and we're good to go. So we'll just briefly dive into these connection properties. There's not much needed here. So we have our IP address to our Mongo source. Here we're choosing which collections we want to read from. In my case, I'm reading from 2 collections, which we'll dive into here in a second, which I'm just listing out, but we also support wildcards. So you can grab entire databases or subset of databases if desired. Then you log in with your Mongo user information, username and password. And then our MongoDB reader, finally, you have to choose if you want to be in initial load mode or incremental mode. Initial load mode, as discussed before, will move any of your existing data already on Mongo, while this incremental mode is our CDC or change data capture mode, so capturing any live replication. And then you'll see our Mongo Cosmos writer looks remarkably the same. So our connection URL to Cosmos, our login information, and then how we want to map those collections, which also are supported with wildcards. We also have the concept of parallel threads in our Mongo Cosmos writer. So if you want to parallelize the initial load process, we'll create Mongo Cosmos writers, parallel instances under the hood, and this really increases your throughput to Cosmos.
I got a question about that. How does that parallelization work? So if you were saying in a sharded Mongo cluster, does it do it across the? I'm guessing it's kind of smart about how it utilizes resources and hits the shards, or is there something else kind of?
Exactly. So in this case, you can only use the parallel threads field in the initial load mode, and Striim will handle the rest. So we'll distribute the data within Striim in a round robin fashion across these threads. But you will not use, this is why I don't have this selected to be used in the CDC application, because this is naturally disabled in the CDC applications just to maintain transactional consistency.
Got it. And then, so you have, I'm also confused, or I just want to ask a question. So you have one job for the initial load, and then another one that does all the CDC. How does the CDC know? I mean, is it doing a checkpoint? Is it right? Like in our change feed, we're basically just using the LSN, and you would use essentially change feed to do initial load and CDC after that, and it just kind of starts at the beginning, and then just keeps rolling forward, and then just checkpointing LSNs as it goes through and writes data, right, or emits it out where it's captured in our release collection. How does that explain that process for you guys? Is it similar in that regard, where it's using an LSN for the data to keep an idea of where it's at?
Exactly. Yeah. So both our initial load and incremental mode are reading from the oplog change file for our Mongo source. Now, naturally, if you start the CDC application, it will just start picking up any live changes from the time that you started. We also have this property called a start timestamp, where you can set your start timestamp and go back in history and start wherever at that log file you want to.
Got it.
So realistically, in a migration, you'll start the timestamp from where you want and coordinate that with your initial load. So from whenever you started your initial load, this doesn't need to be exact science, but we'll parse the op log from there on forward.
Okay, cool.
And then also just to add on to that, we were constantly checkpointing where our cursor on the op log. So if your Striim application were to crash, or you would lose connection to the target database, for example, those checkpoints are being held, so you can naturally just resume your Striim CDC application from those checkpoints.
So what if it crashed between fetches? So if I fetch data and I get a whole set of changes, I'm guessing it does like a polling to see if there are any new changes from the last time it processed, and then commits that data in the secondary store wherever you're writing it to. What if it crashed during that process? Does it go back after it's committed the data in the secondary store and say, okay, that data has been processed?
Exactly. So we're keeping a checkpoint on the source from when it left the source and when it entered the target, so we can capture the difference.
Got it. Okay, that's good. Yeah, because it's cloud, things crash, right? So,
of course.
Yep.
Great. So that's what I wanted to show for this. This is, again, just the simplest configuration you could have for a CDC application. What we wanted to demo today is something a little bit more advanced, showing some of the processing capabilities. So that's this third application here. It's a CDC application with a merge processor. So I'll jump in here. This looks almost exactly the same in terms of our Mongo reader, Mongo Cosmos writer, same connection properties. The only difference is we've added this open processor called Mongo merge processor. This is something that I've written using the Striim SDK and a few lines of code, imported into Striim, and now this will process all of the data that we're ingesting. So just to give you a high-level idea of what we're trying to accomplish with this processor, I have a couple example documents that we'll expect in the Cosmos side. So here we have two collections in our Mongo source. We have a T order collection. You can consider this the parent collection in our demo example. And then we have a second collection in our source called T order items. You could consider this maybe the child collection. So when we move data from our T order collection, this is how it will land in Cosmos, just all the data being moved over. But what we want to do with the processor is any inserts that come from our T order items collection, we want that to be embedded into this order items field that came from the initial insert. And we are matching these accordingly based off of some order ID. So maybe after I make 5 inserts to our T order items collection, they should embed into this original document and look like so as a result.
Yeah, this is cool. So this is what we often tell customers when they're migrating Mongo to us is, we don't support, joins across collections and stuff like that. But for us, it's the right way to model this data is to embed those items inside that document so that you can fetch it with a single request and also create it with a single request too. So you get higher efficiency in there. So that's cool that you can actually do these kinds of transformations to the data. And you're doing that using your custom merge task or job there?
Correct. So let me dive into that part and how I actually accomplished this with Striim, now that you understand what our goal is. We have a open processor component. So that's what was dragged and dropped here. So I wrote Java code, which I'll show here in a second. But essentially, you name your component. You choose the adapter that you import, in my case, Cosmos merge. And then you name your input stream and your output stream, which would be these two components respectively. So my Mongo stream CDC merge and outputting to my Mongo stream process. I already have that set up here, so I'll cancel this. But let me go ahead and show you what this code actually looks like. So again, this was using the Striim SDK that comes with any implementation of Striim. all you have to do, and this is in Java, we are a Java platform, but you could write any Java, put any Java wrapper over code from any language, and this will still work. But here, just using that Striim open processor library, and the rest of the libraries you see here are just ways to manipulate JSON objects. And the only function that you have to implement in the Striim SDK is this process event function. So this will process every event that Striim ingests from your Mongo source. And all the code that was written to accomplish this is right here, which is exactly 40 lines of code. And let me just go down at a high level to explain to you what we're doing and why the Striim SDK is so useful in making this process easy. So at first, we're saying if we see a T order collection from our source, if this is an insert from the T order collection, we'll just ship the data over as expected. However, we want to add this new order items field as an empty array to prepare it for future embedded inserts. So for example, that's giving us this case here, now with an order items empty array. Now, in any of the cases that we see an insert from the T order items collection or that child collection, we have some work to do. And that's really just setting up the JSON document structure that we desire. So that's all this code here. What's most important is simply telling Striim, now that I have my new data format, tell the Striim SDK to change the data to that new data. Tell the Striim SDK that instead of being an insert operation, this is now an update operation, because we're essentially updating the existing document in Cosmos with an embedded array. And how should we update? We should update on this document key. So really, these 3 lines of code are the most important into telling the Striim SDK how you want your behavior to be.
Yeah, this is great. Very cool. And this doesn't look hard. So you said earlier that your SDK uses Java, but you mentioned something about a wrapper. What was that?
If you want to import any library that converts code from another language into Java, and that's supported, you can do that within your file here, and Striim will interpret it just fine. So we've seen customers, write their code in Python, throw a Java library wrapper over it, and it works as expected.
I see. Okay, so you don't have native Python libraries or NuGet packages or any of that stuff. It's basically Java, but you'd have to you just have to put it in a wrapper.
Exactly.
Okay. Cool. All right.
Yeah, so we can jump, if there is any questions, we can jump more into, the actual code or the SDK. Happy to do that.
Let's see. I got another question here. Pick one of these. How do I decide how many parallel threads to use?
Yeah, great question. So the parallel threads is limited to the number of cores you're running your Striim VM on. So in my case, I'm running a 16-core VM in Striim. So I wouldn't want to use any more than 16 threads.
Yeah, makes sense.
And that's because we'll apply a new writing instance to each thread to parallelize that process.
Yeah. Okay, makes sense.
Great. So I think we're ready to actually run the application now. I'll go ahead and let's first confirm. So we're going to be landing our data in this orders enriched collection in Cosmos. Let me just make sure that that's empty. We have no documents there. I'll go ahead and deploy this application. And now we're running. You'll see we're not getting any input. That's because it's waiting for live replication changes. So I'll go ahead and make our first inserts to our T order collection. So the parent collection, if you will. And we can see those 3 went through. So we'll go ahead and refresh our documents. And here we go. Just like the example I showed, we'll have 3 parent documents here with IDs 1, 2, and 3. And now when I make these new inserts into the other collection in our source, we'll see them embed based off of that ID value accordingly. So I'll grab these T order item inserts, which are inserting 5 embedded documents into each of our 3 parent documents. Those went through, and we can see them, the output in Striim. So we'll go ahead and refresh our documents in Cosmos. So now if I go through our documents, we can see those items from the T order items being embedded into our first original 3 parent inserts. And we can see that for 1, 2, and 3.
Yeah, very cool.
Now, of course, this can work indefinitely for any amount of embedded inserts or for any amount of parent inserts here. So I could simply paste a lot more inserts into our Cosmos source, verify that they're going through in Striim, refresh my Cosmos instance, and we can see, for example, that those embedded documents are growing.
Makes sense. And you got the CDC running. So if I delete some data over in Mongo, that's going to get picked up, right?
Of course. So any inserts, updates, and deletes.
Yep. Makes
if we
sense.
go into the monitoring page here, this will show us the overall health of our Striim cluster. So just showing that I'm running a single node with showing our memory and CPU health, but we can also drill down into individual applications that are running. So for example, we're running that merge CDC application. We can drill down into here and take a look at our target component. So that Cosmos Mongo writer, see that our events in are matching the events out. And we can even check values such as end-to-end lag. So for example, even with that processing component added, we're still reaching millisecond end-to-end latency. So the time it takes from inserting on the source to actually land on your target using Striim. We also have more details, which gives you a plethora of other monitoring details you might be interested in, such as your operation count. One more thing I wanted to show with this processor is using the SDK, it seamlessly works also for the initial load mode. So if I were to stop this application and change my Mongo reader to be in initial load mode, what this is going to do is now read any existing data in our Mongo source. Since we just made those inserts on Mongo, all those inserts are still there on the T order and T order items collections. And this processor works seamlessly. So let me just delete these existing records to avoid any duplicate key issues. And I'll run this Striim application. So you can see this data flowing live through our data pipeline. All of those inserts we just previously made are being captured with our bulk load. Everything's been outputted, and if we refresh our documents, we'll see all that data was processed and embedded as expected, also in this initial load mode. Just a few more things to add here, and then we'll save some time for questions. Here you can see we expose obviously the row data from Mongo, but also the metadata that comes with all of these events. So we've seen users access this via a REST API or console and use this to create their own monitoring solutions. I already went through the monitoring page a bit, but you understand we have our own monitoring solutions. And we also have an alert manager. So based off of this data, you can get SMTP text or email alerts for maybe at the node level if your node memory usage exceeded some value, or at the application level, maybe your application crashed and you want to be notified when that happened, or if an application was deployed or started for that matter. And then even at the component level, so for example, if your CDC stream has reached 0 events. And everything you've seen me do through the UI today is also can be accomplished from our console. So you can either use an external console or a built-in console in the UI, which gives you a more programmatic approach to using Striim. So we can do things such as monitor an application. If I can just grab this name here. And for example, you can get deeper monitoring metrics from our console to take a look at your data pipelines. And last thing here to ultimately show before questions is that all of your Striim applications are backed up and defined by what we call a TQL file. So I can export this application, for example. Open this up and you can see that this looks a bit like PL SQL, but essentially this defines how your application is configured, and you can use this to export and import across Striim applications. You can also use these TQL files to programmatically design applications or even deploy them from the console or using our REST APIs. So essentially with the alert system, the console, these SQL files and processing, you can really create a very flexible, very managed experience around Striim.
Yeah, this is really quite impressive. Nice polish to the experience there, and I like, obviously being able to do customization in terms of the transformation of data is certainly critical when you're using something like this to do modernize your applications or your databases behind there. That's very cool. So, question: you talked earlier about you want to match the number of threads to the number of cores you have. What if I and I don't quite understand your building. So do I start small, like on a small Linux VM, and then do I scale up? Like say I want to do some tests, right? I'm not going to do, migrate hundreds of terabytes of data at the start. I want to like build these custom connectors and other pieces so I can, I have to design this thing and I want to test kind of piece at a time. So do I start with a small Linux VM and then just pay for that? Or explain to me kind of how your building works. Is it I have to pay for the VM and then Striim on top of that, or what?
Sure, yeah. I mean, Edward, you might want to take this one on my behalf.
Yeah, sure thing. So ultimately, Striim is licensed based on the number of cores of the VM that you run Striim on. So typically, as part of an engagement, we'll go through a POC, and as part of this POC, we'll recommend a size of the VM to run on based on the amount of existing data in your database and the amount of change data per day or per hour. Typically, a license will be an annual subscription, but if you do have a one-time migration use case, we could take advantage of the migration program that we have in place to help subsidize the license cost. But yes, ultimately, say for example, if you're running Striim in Azure, you would pay for the the VM cost, which is typically a pretty nominal charge.
Yeah.
And then there would be a separate license directly through Striim.
Okay, I got it. It makes sense. So it's kind of based upon the amount of data you've got or going to ultimately migrate, going to dictate the size of the VM, also how long you need. And then, of course, whether it's a one-time migration or an ongoing, streaming scenario where you're trying to keep two systems alive or online, and that makes sense. Versus whether you'll do a one-time type of thing versus a subscription model.
Exactly.
So, yeah, that makes sense. So I'll put your email address. So if people want to learn more and reach out, I'm guessing they could just email you guys here and then get more information, maybe set up a demo or something, or learn more about this program you've got.
Yes, yeah. Please reach out. We're happy to discuss any use case, provide suggestions, or actually help install Striim in your environment and get you up and running quickly.
Right on. Well, that's really cool. I love having you guys on the show. Like I said, a lot of customers that come to us are looking to modernize their applications, right? They may be coming from, typically, in a lot of cases, coming from like an on-premises environment, and they're running legacy systems, and hey, it's time to get into the cloud, right? And get your apps in a cloud environment, so you're not running on the bare metal or running in a colo or a cage or something. And they need to get to the cloud. And you guys have created some really nice software here and service to help customers migrate the hardest thing of all. Really, it's the database, and get that from wherever it is into Azure. So thank you very much. This was great having you guys. Really liked seeing what you did and seeing just really how it's not that hard really for getting started here and using this. And then I'm guessing you guys are around to help customers when they do kind of need some extra help, right?
Exactly. Yeah. So if you choose to move forward with the program, you'll actually get the pleasure of working with Jordan, and I will help you out directly.
Cool. Well, hey, Edward and Jordan, it was a pleasure having you on the show. Thank you very much for coming on, and thank you everyone for joining us and watching Striim and this really great streaming software they've got for either doing modernization or just ETL or migrations, all that. So just some announcements. I've only got one show left for the rest of this year. I'm going to have Justine from our team on. She's going to talk about new Logic Apps connector built for Cosmos DB. That's going to be pretty exciting, and you'll definitely want to check that out. That's going to be on December 16th. So taking a week off, and then have her on Thursday after next. And then we're done for the rest of the year. We'll start new episodes beginning of the year in January there. If you haven't heard already, we've got a new virtual user group. Come and check us out. We've had 3 meetups so far. You can join us. These are live. We've got 3 so far. You can come and watch. Go check out the sessions on demand. And we'll get some more of these scheduled as we get into the new year as well. So come and join us there. And you can join up to the meetup and then get notified when we schedule new meetups coming as well. We may not have many episodes coming for the rest of this year, but we've got, now 34 of them available on demand. So come and watch Azure Cosmos DB live TV. And you can check out all the cool former or past episodes we've had. So that's it for this week. Edward, Jordan, thank you so much. It was great having you on the show.
Thanks for having us.
Yeah,
okay.
Thank you.
Thanks, everyone. We'll see you next time.